Yeah, that's why your calculator was found. Oh! Anyway, so you've got two types of disks. And, excuse me, you have, you don't know how many of them you're going to spend, but you know that you've got, one of them is $1 for the double density, and the other one is a $1.25 for the high density, and the total amount spent has to be $6. Okay? Do you agree on that? And then the other one, what we're going to do is you have the storage space, 720D plus 1440K has to equal 6480. Now, graphing this is dumb. I'm not going to lie to you. Graphing a problem like this is dumb because right now all of you guys are sitting here going, but wait, one of those variables is already by itself. Can't I just use substitution? Or at least I hope that's what you're thinking. No. Do you guys remember that, substitution? When you're doing linear combinations? All right. What happens here, and this is where we're going. This is where we're going to today. That's okay. This is where we're going to today.
What if you just use X and Y?
You can. I just use that. What happens here is, let's say you have, this is just a breakpoint here. If you have x plus 2y equals 8, and then you have 3x minus 6y is 42. I don't know. I'm making up numbers. If you were going to solve that system of equations, there's 3 methods you can do. Graphing, which we were doing yesterday with our calculators, it's not that bad, but it tends to be a little bit tedious when it comes down to solving for y, and you get nasty looking things sometimes if your calculator is really, really fancy. It just takes a little bit of a while because the windows are kind of messed up. Another method that we're going to be using today is using elimination, substitution, or linear combinations. What those basically boil down to being is there's the 3 ways of solving the systems. If you have a variable by itself, or excuse me, if you have a variable with a coefficient, remember what a coefficient is? Yeah, the number by the variable. I don't have any, go to the bathroom. Coefficient of 1, use substitution. He was looking for, yeah. So in this case, I have a variable by itself with a coefficient of 1. I can say that x is 8 minus 2y, and I would substitute this in here and solve for y, and then re-go back in for x. It's more efficient than graphing because when you get to something like this, you don't want to have to graph that because your intercepts and where they're going to run into each other just turn out to be a big pain. And that's kind of okay. Now, in this case here, do you see how I have d has a coefficient of 1? Everybody with me on that? So what I'm going to do for this is I'm going to get d all by itself. It's supposed to work. There. So d is 6 minus 1.25 h. Do you agree? From here, I'm going to take this value and substitute in here, and I get 720 times 6 minus 1.25 h. Why did I use a k here? Sorry, it's supposed to be an h. Plus 1440 h equals 6480. Now what I'm doing is I have created one variable. A 2-step equation with one variable. What? Huh?
I get it.
You guys are all nerds. Oh wait, and I'm the one teaching you. What does that make me? Ergo, if the shoe fits. I thought you were laughing because I thought this said ish. But this case, I'm going to steal your calculator because math is hard for my brain. And because I was good at it, kind of.
I used to be good at it.
I was very good at using the calculator. Yeah. Beep, boop, beep, boop. All right, so with any luck, now what I was able to do here, instead of trying to figure out the intercepts of a problem like this, I just went ahead and started to use some substitution method. And this is the kind of stuff we're doing today. We're using these linear combinations, substitution method to solve systems of equations because it is a lot more efficient. So to be honest with you, I was kind of hoping you did struggle on the word problems because the graphing is going to be a pain in the butt. Because I'm a jerk and that's how I roll. Speaking of jerks, anyway, Mom.
Another question on a different.
Yes, sir. Now, hold on, Ms. Butler. You see how now I know what the value of H is? I can find D.
Yeah.
I just substitute it.
Okay.
Okay. Yes, sir.
I think the question was like selling. I can't remember. It was like tickets or something, but you get like points for like selling a different amount of each. Like, how do you like add points into like what problem? I think it was like 54. You had points for different.
They gave you the equation, and they told you. Oh,
What do you do with the points? Like,
What-
it says like if you sell this, you get 2 points. So it's supposed to be like a contest.
oh, that's your total points. I see what you're saying. Okay. So the book club you are which blah 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 earn bonus points towards purchase of books. Each paperback is $6.95, earns you 2 bonus points. Each hardcover is $19.95, earns you 4. Your first order comes to a total of $60.75, and then you earn 14 bonus points. How many of each type of book did you enter? Okay, what they're telling you here is that the unknown that you have are your paperback and the hardcover. So for paperback and hardcover, those are the 2 things that you're working with for both equations. You know that your total amount of bonus points was 14. You know that you earned 2 points per on the paperback and 4 points per the hardcover. Okay, that's where the points get used. And then the other one is the money, $6.95 and $19.95, and your total was $60.75. I heard someone say substitution again because I'm a jerk. Yes, and here's one thing that I would do real fast. You guys all notice on the second equation here, the 2p plus 4h is 14. What do they all have in common?
2.
They're all multiples of 2. I can divide everything out by 2. And I get p plus 2h is 7, so p is 7 minus 2h. Substitute in, solve for one variable. I know. Don't throw anything at me, Bob. The dictionary, yes. I could use that as well as a thesaurus.
It was called a joke, guys.
Thanks, Mama.
Oh.
You had a little bit of redeeming quality on that one. I appreciate it.
It's like a
Yes,
joke.
ma'am.
Oh.
What's this thing called?
I got it the source.
I had wrong accent on the right syllable. Any others? Oh, that last question. That last question. This is kind of something that I hope that most people will start to do as you get older when you start to spend money.
Yeah.
You research before you purchase things. Ladies and gentlemen, I cannot stress to you enough of the importance of not going to a store, one store only, to buy something. There's this great thing called the internet. I heard it's popular nowadays. research, research, research. Because I guarantee you will always find something cheaper. I haven't bought anything at a store that I couldn't buy online because I can find it cheaper. When we bought our car, we scoured everything, and we tried everything local to get stuff like that. I'm sure your folks do the same thing. They're buying something, larger purchases, or even a TV. You can find stuff, whatever. A pair of shoes. So, one of these things that they talk about here is you get the ads. The ad for Store 1 says all digital cameras are 15% off. Ad Store 2 gives you a $300 rebate when purchasing a camera. Assuming that the lowest priced digital camera is $700, write and graph the two equations to describe the prices at both stores. When does Store 1 have a better deal than Store 2? Basically what that's saying is that, bless you, what it's saying is at what point are you getting a better deal between the two stores? One store you save more money at one, and one store you save more money at the other. So what you're looking at here is you're still writing out a generic graph idea. You know that if the camera is 15% off, do you know the quick way to calculate how much the real cost is? Yeah, so it's 0.85. So if you go to the store and you're looking for a pair of jeans and you're at Kohl's or something like that and it says they're 15% off, you sit there and say, okay, what do I do to figure that out? Well, take your phone out and you multiply by 0.85, and that tells you the cost. All right, it's a shortcut way of doing things. Before tax, right? So, Uncle Sam. So what happens here is whatever your cost is, you multiply by 0.85, and then I'll give you your overall cost. Real basic, it's real simple. What happens also is that the other one, you don't know what your cost is, but they're going to take $300 off to figure that out. Does that make sense? The camera's $300 or $700, so it's at least, the smallest price would be $400. So your two equations are basically these. Okay. Now, there's a point at which one of them's cheaper than the other, and what you do is you can still find the intersection of these 2 points. You can mess around with your scale and all that to figure out where they run into each other. But also you could just go ahead and notice what's going to go. I'm getting the look at death review. It's kind of funny. I know that 0.85 equals x minus 30. Oh, excuse me, 0.85x.
X minus 300.
Thank you. I was checking to see if you're paying attention. Way to go. Now, when I move stuff around, 300 is 0.15x. Do you agree? I just made everything positive. You can have negative 0.15 equals negative 300 if you want. It's still going to get the same answer. When you divide out, I think you get 2,000. Does that sound right? At $2,000, it's the exact same cost at both stores. If you're buying a camera for $2,000, it's the same price overall. Okay? Now, all you have to do is figure out which one gives you a better deal above it, which one gives you a better deal below it. So pick a number bigger than that, and that's where you shop. Pick a number smaller than that, and that's where you shop. All you have to do is to say, what's 2001? Substitute into both those equations, see who has a better deal. Does that make sense? Yeah. All you're doing is comparison shopping.
You ever seen that show,
Extreme couponers? Yeah. Those people are crazy.
They go in there with 6 shopping carts, they put them $10.
Yeah, those people are crazy. Because if you sit there and you think about what they're doing,
They're wasting their time.
I get
They're
it.
saving money, but they're wasting their time.
Well,
They could be. Oh.
yeah. The other method. What's that? There's the other one. The other one that we don't like to talk about so much is called linear combination. With linear combination, what you want to get is you want same coefficient with the same sign, or you want same coefficient with the opposite sign. Because what happens is if you have the same coefficient with the same sign, what could you do to eliminate them? Subtract. So if you have same coefficient with the same sign, you can subtract. And what I mean by subtract is that we can subtract the two equations from one another. Whereas if you have same coefficient with opposite signs, you would just add them together. But sometimes it doesn't work out that cleanly. Sometimes you have to create same coefficient, same sign, or same coefficient, opposite sign. Like this example here. 2x minus 4y equals 13. 4x minus 5y is 8. There are more than one way to set this thing up, but I want to get same coefficients with same signs or same coefficients with the opposite signs. Which coefficient do you want to eliminate? Yes, ma'am.
We can multiply the first one versus -2.
Okay, perfect. I can multiply that first equation by -2. Now, when I multiply the first equation by -2, make sure you multiply all three parts by -2. A lot of times, students remember to do the first two, but forget the third. All right? Now, what I'm going to do here is I'm just going to rewrite this multiplication problem directly below the second equation. Again, -4x plus 8y equals -26. Everybody see that? Yes, sir. Because what I'm doing here is I have now created same coefficient with opposite signs with the 4s. Because the next thing I do is I add them together. -4 plus +4 is 0. -5 and 8 is 3. 8 and -26 is -18. All right, yeah. What's y? -6. What I'm doing here is I'm eliminating one of the variables, picking whichever one you want to go with, and get rid of it. Now, you could have eliminated the y values by multiplying the top equation by 5, the bottom one by 4, and subtracting. You could have done different signs with them as well. There's more than one way to set these things up. So if I get y is -6, how do you figure out the value of x then? Wait, you have electrical work? Good work. Stay grounded. I am really not that funny.
Yeah, you are.
No, I'm not.
You're hilarious.
I'm really not, and I agree with that statement. I think I am, but I know I'm not.
It's not as funny.
There. And is it okay to have a decimal?
No.
Fraction, whatever.
Doesn't matter. That's the answer.
Just, I would leave them in simplified fraction is fine. Your book will leave them in a fraction form if you have to check your answers. Okay?
You can check your history.
If you have, if it's an odd number. But most of these numbers are even. Well, they're even and odd, so. No, they're mostly even. He's thinking. I see him, he's like, wait, what happened? All right, try this one.
Do we have to use the same metric for that method?
Yeah, what happens now, I'm going to use whatever method you want to use here. It doesn't matter which method you choose. I'm looking at this right now, and I could probably do this in 3 different ways. There's no right or wrong method to start with. Some methods are easier than others. It just depends on how you think about it. Okay? So give this one a shot. That's where we're at. Now, there's a couple of ways you can go about this one. Did anybody divide the bottom equation by 5 and get x by itself? Yeah. I would have done that 'cause it's a lot quicker.
Oh, I didn't get
Now, that's fine. You can get y by itself too, yeah, just by adding the x over real fast. Now, That's great. It's a real quick method to do that. If you did not do that, I guarantee, I bet you that most of you guys multiply the top equation by 5, the bottom one by 2. Anybody do that? No. What'd you do?
Top like 5, bottom like 2. That's what I was
Oh, okay. The only reason why I say, because then you were going to subtract them. You were going to eliminate y's. That's fine as well. One thing that I would suggest to you guys, anytime you see coefficients with alternating signs, the x's here have alternating signs, eliminate them. Because you don't subtract them. Because what happens a lot of times when you subtract with all the negatives, you might make a mistake. That's just my opinion because that's what I used to screw up. And I'm only assuming that maybe that would be an error that somebody else might make, not maybe you. But I'm just saying, it's taking one negative out of the equation, literally.
What did you say the other method was?
Oh, getting y by itself. Because you could divide the whole bottom equation by 5.
I thought you said something further, some other.
Oh, the first one, the way that I would probably have started this, because I saw alternating signs, multiply top by 5, bottom by 2. I think that your way is perfect, because you probably took it 3 steps and you're done. But when I see the alternating signs, I just think that right away. So I'm going to go that route, and then I'm sure you got the same thing. If I multiply the top one by 5, bottom one by 2, you get a new set of equations. 10x plus 15y is negative 5. Negative 10x plus 10y is 30. When you add them together, these go away. You get 25y is 25, y is 1.
Wait, I got 5.
Oh,
Y equals 5.
I did that too. Oh, that's not right.
I got you.
Oh, because you subtracted.
No, I added them together.
No, because I got y
we
equals 5.
Oh, yes, then you subtracted, okay? So now, substitute back in. 2x plus 3 is negative 1. Oops. Let's working ahead there. 2x is negative 4. X is negative 2. Is that what you got? Negative 2 and 1?
Yeah.
We're on the same page. There are multiple ways of doing these problems, ladies and gentlemen. It's not too scary. Let me give you a couple of these to do for the weekend. Do those, please. It's 8 problems. There are 6 systems and 2 word problems. The 6 of them, it says choose whatever method you'd like to use to solve it. Some of them are going to be easier to use substitution. Some are going to be linear combination. It's up to you just to make the decision and go for it.